Probably not even that. And then we've got this wonderful little activity over here, which I hope will work. Now, quick little rehash. You've probably forgotten a lot of stuff over the weekend, but if we have a position time graph, rise over run. Who can tell me what the rise over run gives us? The gradient. What does the gradient give us in this context? The speed. Okay, so very quickly, I've just made this up. Your graph should be, have 3 kids' sets of data and go up to 70, but I've just quickly sketched this. I've got 10 meters here, and I've got, 9 to 13, which is 4, and so that gradient might be 2.5 meters per second, for example. Now, the last question I asked you to solve was this one. And then I think everyone got to that and we went home and had a great weekend. But what I asked you to do is to look at the smallest time interval. But we were limited because we only had measurements every 10 meters. So when someone was running, they had to run past the 10, then the 20, then the 30. So we don't know the motion between. All we can say is from there to there, it took this amount of time. So if I go back to, I've just joined that dot with a straight line. But for all we know, if I zoom in, maybe his motion was actually like this. And it's sort of, boom, 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 boom. Maybe he did that. If you have a think, every time your lead foot hits the ground, you're going to slow down a bit. And every time your back foot pushes off, you're going to speed up a bit. So you're not really traveling with in a constant speed. And in fact, they've measured the 100-meter sprinters with really accurate motion sensor, and you can literally, looking at the position time graph, you can see each of their stride lengths just by looking at the way that their position time graph goes. Every time they kick off, they go a little bit faster, and every time their lead leg hits the ground, they slow down a bit. Okay. Now, we said, all right, there was one time interval which was exactly 1 second, which we could say this one here, if I said here, that's 10 meters over 2 seconds, that's m equals 2.5. So we can say, all right, that was the greatest gradient for that interval. If we go back to this, we could repeat this experiment, right? But instead of every 10 meters, what if we had more student involvement? What if we had a student every 5 meters? How would that look? If I had a student every 5 meters, what would be different on this graph? Would somebody like to give me their input on what would be different? Huh? You're just scratching your head. Your head would still be itchy, yes. There'd be more points, yeah, there'd be more dots. So but here's the thing, is the dot going to be exactly in the middle? It might not be, but for now, let's just put the dot there and there and there. What if, and it's going to break down in a second because we're going to run out of room, what if we had someone every meter? What happened? Oh, I changed him to thick red, look at that, cool. What if I had someone every meter?
It'd just be dots.
There'd just be dots all over the show, okay? Oh, I've stuffed it up already. And then, hold on. My scrolling is not happy. Then yeah, if I had every meter, you would have this sort of bullets, machine gun, boom, 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 and you could pick every single meter, right? You could go rise over run, 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 rise over run. This is getting a little bit closer to our next topic. Obviously, we were limited. We didn't have 70 students that could stand there with 70 stopwatches, each 1 meter apart. But if we did, you could literally get per meter a time. Okay? Scroll to the next page, or if you have the paper version, I should say turn over. Now, I took the data from a previous class, from a previous year, and they did exactly the same thing, but what Excel manages to do, you've got options of how you can express your data. You can have it like straight straight lines to dot points, which is kind of what I had. So straight line, straight line, straight line, straight line, and it's a very jaggedy sort of boop, 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 boop. But it has this smoothening function or a curving function where it makes this lovely sort of curve. Okay? And this is why I want to display it like this. This could be, imagine we had, if we zoomed in here, imagine we had a timer every 10 centimetres. So from 0 up to 80 metres, that's 800. I imagine 800 stopwatches, and as you ran past it, they're all going stop, 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 stop. And this curve was made of 800 dots. And we can zoom in and do the rise over run anywhere we want. We're getting closer to your speed at any instant. Okay? Not just, your speed for that 10 metre segment, but any instant, that's what your speed's doing. Okay? Now, in order for us to do that, in today's lesson, gentlemen, we are learning about instantaneous. It's the velocity at any instant, or it's the gradient at any point. Okay? Exactly what I said with my voice, with my mouth just then. We are limited by our measurements of time or distance, but what we can do is draw a tangent line. Now, here's what I would like you to find. On the bottom here, I'd like you to just take your pen and do it properly, don't be silly. Just take your pen and just make a curve. So rotate your wrist and make any curve like that. Okay? Just a curve. So start in the bottom, put your wrist on the bottom corner and just rotate your wrist to the top, make a curve. Now, obviously, we could do a little rise over run. Here we go. At the start, it's very steep. Rise over run, a lot of rise for every run. And as we go along, the steepness starts to decrease. And at the top, it's got a very low gradient. Okay? Now, here's where you need to have a little bit of practice. Put a dot somewhere on your curve. I'm going to make it a little bit larger so that you can see. And what you're now going to do, and I'll do this on the board, you're going to grab your ruler and you're going to grab a whiteboard marker which has been stolen from this classroom. So you're going to pretend. You're going to grab your ruler and you need to line. Now, what you need to do, a tangent line is parallel to the curve at that point. So what you need to do is get a line that just kisses that point, and either side it goes away. Okay? Now, you could have, that looks a little bit too steep. I seem to have the tangent there. That seems to be a little bit too shallow. So you've just got to line it up, and then I want you to go it across. So your tangent line should just kiss the curve. It shouldn't go on the other side. It shouldn't cross it. Okay? Yes? You did this last time.
Yeah.
Show some initiative and use the side of your book or something. So, I'm going to try my darndest. All is not lost because I think there we go. Now, I can fake it because I've got the option of doing this. I can move that looks pretty good. Maybe I could rotate it slightly. Okay, perfect. Now what that enables us to do, if this was on a graph, and if we had some grid lines, some vertical and horizontal lines, then I could plot in my run and my rise. Okay? And so, the gradient of that blue line is the gradient at that point. Okay? Not before, not after. I don't care about what the gradient was down here. I don't care about what the gradient was up here. But I can go, right, the gradient at this point of the curve is going to be the gradient of that blue line, the tangent. Have you guys done tangent lines in maths?
Yeah.
Good. Well, you're going to use your mathematical knowledge to answer these questions. So, it takes practice. It's an estimate, gentlemen. There's no one correct answer. You might come up with 4.5. You might come up with 4.9. There's going to be an appropriate range, okay? And it's how well you can draw it. So we want to find Ben's tangent line at 14, or Ben's curve tangent line at 14 seconds. So Ben is the red, and we're going to go up to Ben. 14 is there. Boom. So I'm going to zoom in. Now, gentlemen, the trick with tangent lines is you need to draw it long enough, and I would stop on one of the lines. Now, you can either stop at a vertical or a horizontal, but try and go from a vertical to a vertical or a horizontal to a horizontal. For example, I might choose to do all the way up from that. Oh, look, there's a nice point. That ends there and there, okay? Now, I don't even know what the scale is. I'll worry about that later, but let's just, could you do this? And then plot your line down. Okay. Now, if I'm overly critical, I think my tangent might be slightly steeper, but they seem to be parallel at that red dot. And now we can zoom out and figure out what the tangent to that tangent line is, what the gradient is.
Do we do it like 1 decimal place?
Yeah, one should be fine. Now, see where I've gone? I've started at 25. Each of these squares is 5. So 5, 10, 15, 20, 25, 30. So my rise is plus 30 meters. Can you read that from the backs, gentlemen? And now here's my run. 1, 2, 3, 4, 5, 6. 6.2. So I would then go now on the next back over here. I don't want to write too much on the graph because we've got to do this for other parts. So let's go over here. M equals 30 meters over 6.2 seconds. 4.84. Okay, approximately. So depending on your tangent curve, you might get a different gradient. But I would probably, if this was a test, I would allow, I don't know, plus or minus 0.3. So you can get as much as 5.1 or as low as 4.5. If you're in that range, then you're okay. Okay. Next, Tristan at 20. Tristan at 20 is blue, and we're going to go up to there. And hopefully your previous gradient line isn't going to interfere. We're going to try and draw. So again, don't try and get your tangent line to intersect with any of the horizontal or verticals. Just put your ruler down, try and make it as parallel as possible, and then worry about that later. That doesn't look too bad. Now for this one, there is no nice intersection, but I'm gonna go along the horizontal because the horizontals go up in 5s. We can worry about time later. 5, 10, 15, 20. Okay, so you can see what I've done here, gents. I've chosen to start my rise along this line, and then I've started it along that line. So this one's nice and easy. You just go boop, 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 5, 10, 15, 20. The time one might be a little bit trickier. We'll have to go down and figure out where we're at. We're at 16, 17, 18, 18.4. And across to 19, 20, 21, 20, 22 point, maybe 3. That's an 18, by the way. And so that is 3.9. Now, again, don't copy down your gradient might be different, your tangent might be different, but that's what I've done. There are other things you can do. You know, you could, if you wanted to, you could go all the way down on your graph with your ruler and write it down here, 18.4,
Sir,
all the way down. Yep.
if it's around like kind of an easier number to do, like if it's I got 18.5 to 22.5.
Perfect.
So
Then call it a.
like if it's around that,
Yep.
you just like change
Well,
like,
you're going to be dividing by 4. I'm going to be dividing by 3.9.
Yeah.
Our values are going to be slightly different, but they should be okay. They should be all good. So 20 on 3.9 for Tristan. $5.13. Okay. Okay, now on this pre-made graph, the last question, gentlemen, I'll ask you to do it yourself. Find the steepest part of any of those curves. It looks like it's Kyle at the very end. You can see what I've done. I've asked the students, well, Kyle ran quite constant. I asked him to sprint. Ben jogged, but you can see even in the last 40 metres, Ben he increased his speed. And then Tristan, I said, all right, start off sprinting, and then a slow jog, and then run at the end. So again, I did the same thing. I asked these boys to do 3 different things, but it looks like, I think right up here, would you agree that seems to be the steepest?
Yeah.
So that's the last one I want you to do, and obviously it's going to be greater than the other 2 gradients that we determined. It's going to be greater than 5.
Can we do it at 9, like 10 seconds?
Yeah, you do it. Yeah, 10 looks good. Yeah, so 23 subtract 17.5. So what is that? 5.5, I think. Absolutely. All right. So again, draw your line, and just as it should just kiss, and then travel on. A bit thinner, move them up, maybe rotate them a bit. Again, it's up to you what you choose, but I've gone now along the verticals, that's plus 2 seconds, and then 5, 10, 15, 20, 25, about 27.5 for me. Approximately, whoa, that's a lot. 13 point, is that correct?
Yeah.
That's 13.7 meters per second. I might put a little question mark about that because that's faster than Usain Bolt, which makes me think that whoever was stopwatch 70 and stopwatch 80, they might have recorded a little bit slower and a little bit faster, and I think they've just made the time interval a little bit too small. But that's what the graph shows us. Okay, the data suggests that the gradient right at the end, he did a sprint in the last, well, he was sprinting the whole damn thing, wasn't he? Okay, all right. Are we all good now? So, how long have we got? Half an hour. Let's have some fun. LabQuest Viewer. And I hope, we sometimes have issues with these things. I'm going to just connect to this here thingy-majiggy. 10.61. So yeah, you can pack away your things.
What is it?
What is, I'm about to explain if this thing connects. Come on, do it. Oh. 10.61. Oh, no, I thought I saw something. 10.61, 248.167. No? Oh, we're on. Okay, we are live. All right. I always have a bit of trouble with this. It always dies or loses connection. I need a volunteer up the front. Come on, McNeely, get up here.
It's the first one that we've done something with this.
All right. Now, gentlemen, what this is a little LabQuest data logger, and we'll have the opportunity to play with these throughout the course. Oh, and it just changed it from portrait to. Let's go back. Go back. And this is a motion detector. And what it's doing is it's sending out a high frequency tick, and that travels out at the speed of sound, which it's estimating to be about 342. And then it's going to strike an object and reflect. So what it does is it sends out a tick and it listens for the echo. So when it bounces off Miles and comes back, it'll come back in a certain time. And the LabQuest, it goes, all right, I sent it out at this time and I got the echo at this time. So S equals VT. S currently equals 1.31. All right? Now, it's sending out every about once a second. It's going tick, tick, tick. So it's going, where is Miles? Where is Miles? Where is Miles? And at the moment, he's not really moving. Okay? When I set this to go, to record, it sends out, it goes, where is Miles? Where is Miles? It goes about 10 or 20 times a second. It sends out pulses. So what I'm going to get you to do is just stand about half a metre away. And when you hear it go into like machine gun mode, when you hear machine gun mode, I want you to just walk to the back of the room, to the bench, and then back again, and just make sure you stay in the beat. All right. So we'll record. Go. And then back. Perfect. All right. So here is our position time graph. You can see, look, it was stationary. Now let's find out for how long, right? So I can tick here. He was stationary for 0.85 seconds at 5 meters, and then he started to move away. I could say from there to there. Is it going to give me, well, I could say, I don't know, in about 2.4 seconds, he went from 0.5 to 2. He's gone 1.8 meters and 2.5. I could do rise over run. But what this thing does, which is pretty cool, and I want you to do this in just a moment. We've got 8 of these data loggers, 8 motion sensors. I'd like you to pick any point on the graph. So let's just go there. We're going to go analyze tangent. Look at that. Boom. And it makes, you can't really see it, but it's just made a little line of best fit. And it's going gradient 0.36. So that was the speed of Miles as he was walking away. And if we track this along, as we track this along, you can see at the start, pretty much 0. Yeah, he's not moving. And then he speeds up to 0.79, 1. Then it goes back to 0 because he stopped. So you stopped when you were 2.4 meters away, you stopped. And then he changed direction. If we go back to here, look, negative 0.68. Now the units aren't there, but it's going to be rise units divided by run units. So it's meters per second. Okay? So what I would like you to try and do is to get a constant, see if you can get a gradient of 1 meter. Now, so for Miles, I go, all right, if Miles was trying this, I'd go, hang on, you were you're actually pretty good there, 0.96. So I want you to try and make a couple of graphs. I haven't really decided. Someone's pinched my my whiteboard markers. But since we've got plenty of time to do this, this is what I would like you to do. I'm just going to put some graphs on the board. and I'd like you to try and replicate them.
Do you want me to sit down again?
Yeah, thanks. Sorry. Have you standing there. Let's go 2 meters in 2 seconds, stationary for 2 seconds, and then back in 1. Let's see if you can make that kind of shape. All right, then let's try 2 meters away, walks to 1. Okay, so 2 meters away, stationary for 2 seconds, walks to 1 in 1 second, and then stationary. These machines, by the way, they default to 5 seconds. So all you need to do is literally, I'm not on the screen anymore, all you need to do is literally press that little play button and it will make a 5-second position time graph. You can change it to 20 or 30 seconds, but for this activity, just a 5-second. Okay. The next one, and this one's going to be tricky, and I want to see who can get as close as possible. I'd like you to start at 1 and try and make this shape. Oh, that's a straight line, by the way. 3 meters in, how long should I give you? Let's go 2 seconds, and then back at 4 seconds. That's time. Okay, so just have a go, but what I'd really like you to try and do is go to analyze tangent, and then again, I'm not on the screen, let's try that again. You go analyze tangent, tick that, and then anywhere you point on your position time graph is going to give you the tangent. Okay, so guys, just have a bit of fun, but at the same time, try and make those 3 shapes. All right, and show me what you can manage. Show me what you can